Hello and welcome to helpyourmath.com. In this video, we are going to look at question 1 for the Math 206.5 final exam in the fall 2024 semester. It did get slightly modified, so I just want to create a new video just in time before the course comes to an end. Okay, so our new question 1 is still all about the operations and functions, but we've kind of changed the format of them. So in this question, we're given 3 functions, f, g, and h, and we're asked to compute various operations on 2 of the functions that we're given. I'm going to go part by part. So I'm going to go to the side where I only have letter A, where we want to find the difference function, h minus g of x. And that difference function, that's just the shorthand for identifying the function. But what I could do is I could split it up and say it's h of x minus g of x. And then this is kind of guiding what to do. It's saying take h of x and subtract it by g of x. Well, what is h of x? Negative 2x squared plus 9x. And I use substitution to do that. Negative 2x squared plus 9x minus, what am I subtracting from it? 6x plus 2. I have to have the parentheses around the 6x plus 2 because I'm subtracting the entire function, the entire expression from that h of x. What I suggest doing is using that property that says you can rewrite subtraction as addition by adding the opposite. It's just here we add the opposite of every single term. What's behind the subtraction? There are 2 terms. It's a binomial, so I change 2 signs. Positive 6x becomes negative 6x. Positive 2 becomes negative 2. Once I've distributed the subtraction, that becomes addition, rendering the parentheses unnecessary, right? So now they're not serving a greater purpose other than just separating my 2 functions. Now I'm ready to identify the like terms. I like putting my answers in descending order, meaning I start with the largest exponent, which here I see is a squared, the x squared. It's the only one of its kind. And I'm going to say I'm just going to go back and label what I'm doing. H minus g of x is equal to negative 2x squared. Now I look for my x's. I have 9x and negative 6x. When I add those, I actually subtract because of the opposite signs, and I get plus 3x. And then the minus 2 is the only constant, and we would just say minus 2. It'd be a great help if we would put a box around our final answer, and there's my difference function. Now letter B says, okay, awesome. So you created that function. Now evaluate at a specific value, at x equals negative 8. We can do this in 2 ways. Because we already found the difference function itself, we can use that, or we could do what I did originally. We could find h of negative 8 and find g of negative 8 and then subtract those values. I'll show both ways because if you don't already have part A done, doing it the other way might be a little bit easier. So let's take a look. We're going to use our answer from part A and we're going to plug in. We know that h minus g of x is equal to negative 2x squared plus 3x minus 2. So now I'm going to go in and plug in negative 8 anywhere I see an x. And h minus g of negative 8 becomes negative 2 times negative 8 quantity squared plus 3 times negative 8 minus 2. From here I would follow order of operations. Exponents have parentheses would, but there's no operations within the parentheses, so then we go to exponents. The negative 8 squared, that's negative 8 times negative 8, positive 64. But that positive 64 wants to be multiplied by a negative 2, which I'll come back for in the next round. 3 times negative 8 is minus 24, negative 24, and then minus 2. Now I can combine, or multiply, negative 2 times 64 is negative 128. Minus 24 minus 2. I can start subtracting these. I mean, the minus 24 and the minus 2 are both negative. That would make a minus 26 altogether. But when we combine all 3 of these negatives, 128, 24, and 2, we're going to end up with negative 154. Final answer. I went into that difference function. I plugged in negative 8, and my end result was negative 154. And just to show the other way as well, this is where we're going to just separate and say we're going to evaluate h of negative 8, we're going to evaluate g of negative 8, and then we're going to subtract. H of negative 8 would be h is negative 2 times negative 8 squared plus 9 times negative 8. Just like we saw in the first way I did this, negative 8 squared is positive 64, still wanting to be multiplied by negative 2. Over here I have 9 times negative 8. That's going to make a minus 72. And then I'm just going to work this way. That would be negative 128 when I multiply, minus 72. And that gives me a nice even minus 200. All right, so that was h of x, now, or h of negative 8. Now we need to determine the value of g of negative 8. I'm going to go into my function and plug in negative 8. That's going to give me 6 times negative 8 plus 2. That's minus 48, or negative 48 plus 2, and that equals negative 46. All right, the last step here, I need to subtract these values, and I have to go in the right order, right, because we can't switch the order of subtraction. H of negative 8 was negative 200. I'm subtracting from that a negative 46. Notice I have the minus and the negative 46. Oh, which actually that makes a plus positive. Now, the two things that I want to combine have opposite signs, so now I actually subtract, and I end up with, well, of course, a negative 154, just like I showed over here. So either I could do that to check my work, or maybe that's just going to be a little bit nicer for me because I didn't already have a part A where I had it already calculated. Next up in letter C, oh, I'm down here now, hi. In letter C, we want the composition function. That little symbol is the composite function. That is not multiplication. If I wanted multiplication, I would either, I'm going to write this down because I don't want you to make this mistake. I would either just say h of g of x, or I would do like a closed dot, right? But that little open circle-y deal in the middle, that indicates to us a new operation that we have for functions, the composition function, or the function within a function. Much like subtraction, the composition function is not commutative, so the way that it's written is the specific order that I need to evaluate this in. This says h of g of x, and that translates to h of g of x. And again, now it's telling me what to do. I want to take that inside that g of x and replace it with what I know g of x is equal to, 6x plus 2. So I'm just going to replace g of x with 6x plus 2. And now this is saying, okay, so now take that function g and plug it into h. So anywhere in h that I see an x, I now replace it with 6x plus 2. Here I go. That's going to be negative 2 times 6x plus 2, quantity squared, plus 9 times 6x plus 2. Much like we saw with subtraction, I still have to follow order of operations. Exponents will be the priority because even though we do have grouping symbols, I can't actually add the 6x and the 2, right? There's nothing I can do there. So either you know the shortcut for squaring a binomial, or you're going to write it as 6x plus 2 times 6x plus 2. The choice is yours, but you have to know the shortcut because we cannot distribute an exponent over addition or subtraction. That's not a thing that creates a sound mathematical situation. I'll use the shortcut just so I can refresh your memory in case you're familiar with it. The shortcut for squaring a binomial, so that's a two-termed thing, is you square the first term, so 6x, that thing squared, is 36x squared. You take the two terms and multiply them together. 6x times 2 is 12, and then we double it, times 2 is 24. So doubling it is the key because think about if these were two separate factors, you would be doing 6x times 2 and 6x times 2. So that's why we double it. And then we square the second term, and that would be 2 squared is 4. I can distribute the 9 in the other term, right, because it has no effect on this term with the exponent. 9 times 6x is 54x, and 9 times 2 is 18. All right, to get rid of the parentheses once and for all, I'm going to distribute the negative 2. I'm going to get a negative 72x squared minus 48x minus 8. And now, final step, we're going to look for the like terms. Negative 72x squared is all by itself. So I'm just going to leave it, minus 72x squared. I have a negative 48x and a positive 54x. I add those together and I just get 8x, 6x, 6x. And then negative 8 and positive 18 make a positive 10. And you might be wondering, sometimes students are like, how do I know when I'm done? This just asked us to simplify, so this is the most that we can do. We don't want to then, it's awesome that 72, 6, and 10 are all divisible by 2 and we could factor out a 2, but we don't need to do that because simplifying wouldn't contain parentheses and we're done. This is it. That's our composite function. This brings us to letter D. Letter D, we're again going to do the composition function. This time we're finally going to use f. We haven't seen f this entire time. It's here in letter D. This one is saying f of g of x. And so again, I'm going to just plug in that g of x. And now I'm going to have f of 6x plus 2. So I'm going to go into that function f, and anywhere I see x, I replace it with 6x plus 2. 3 over 2, whoops, there's an x, so that becomes 6x plus 2. I need to make my fraction a little bit longer now because my denominator grew, and now I want to simplify the denominator. I'm going to distribute the 2, which will give me 12x plus 4 minus 4. Hey, wait a minute. When I go to combine like terms, plus 4 and minus 4, that makes a 0. I'm just left with the 12x in the denominator. I now have two terms. I have just the two factors, one factor in the numerator, 3, and 12x. No, those are terms. I'm sorry. Terms. And both terms have a common factor of 3. So I'm going to divide them both by 3, giving me my final simplified answer of 1 over 4x. Voila, there's the composition function f of g of x. It's also asking for the domain. So we didn't ask for the domain in any prior example because we were looking at linear functions, and quadratic functions are both under the umbrella of polynomial functions, which have no restrictions on the domain. When we have our rational function like f, we will have restrictions on the domain, because a domain means it's the set of real numbers that you plug into a function and you can obtain a real number output. And we can plug in any real number we want to a linear or quadratic equation or polynomial equation, no problem. But with a rational function, we can't have a 0 in the denominator because that doesn't produce a real number output. We can't divide by 0. And so there's two ways that we get the domain of a composition function, of a composite function. The domain of a composite function takes on the domain of the inner function. I'm just going to say, okay, I think we get the idea. Domain of composite function. It has the same restrictions as the inner function, in this case, g of x, and also any restrictions on the function itself. So even though f has some restrictions, that doesn't matter because it's going to be carried over from g if there were restrictions on g, or we're going to find them when we look for the restrictions on what we have as our simplified composite function. Okay, so since g of x has no restrictions, we're done with that. Now we look at the function itself and we're like, okay, 4x is not allowed to be 0. That's a restriction on the domain. What would cause 4 times x to equal 0? If x is equal to 0. And so now we know, let's see, this is my answer to D. Now we know that the domain of the composite function is going to be all real numbers except for 0. In an interval notation, we can write that as negative infinity to 0, union 0 to infinity. And this has been a look at question 1 of the Math 206.5 Fall 2024 final exam. Thank you for stopping by.